I believe the trilemma as proposed by Vitalik is somewhat of a sophomoric attempt at describing a complex problem. We ran ourselves into a corner, and then I had to come up with a solution. And the solution was on the head of a pin. What I had seen is that we had a perfectly analogous system to his fundamental theory of physics. You literally had to come up with something that was convergent in almost perfect analogy to a grand unified theory of physics to actually fundamentally figure out how to scale distributed trustless systems. I think it's because nobody was this crazy as I was, to be perfectly frank. Spending this much time building a system in blockchain, there's very few people that would be willing to do it, especially not knowing that you could get to a result.
Welcome back to another episode of Cypherpunk'd, where we explore money's history, crypto's future, and Web3's role in advancing human rights, freedom, and digital liberty. Today's guest is Dr. K from Quai Network. Dr. K is the CTO of Quai Network, and this is episode 4 in our series on Quai. Today, we're going to talk a little bit about scaling. We talked a little bit about it in the past. And we're also going to talk a little bit about what that enables, what's possible, whether it comes to DeFi and other smart contracts on chain. So welcome to the show, my friend.
Appreciate having me again.
My first question is, before we dive into Quai solutions, let's talk about the fundamental bottlenecks that prevent blockchain scaling. What are they, and why have they been so difficult to solve?
Yeah, great question. So one way to think about a blockchain is actually to start thinking about it as a database. And when you do that, there's very known solutions on how to scale databases, right? So a single instance of a database basically has this property of a lock where if one process wants to write to the database, it has to achieve the lock before it can write, and then it has to release the lock when the write is done. And then this sort of creates a throughput to that database. So obviously a technique to increase throughput is to shard the database, where a certain amount of data goes into one instance of the database and different sort of data goes into the other instance of the database. And in databases, then that's the full story. So, if sort of the record sort of has this type of prefix, it goes into that database. If it has that type of prefix, it goes into the other database. And that's pretty straightforward. Now, the problem that you run into with blockchain is that you need consensus. And to get consensus, you have to come up with potentially reconciliations amongst these shards within the database. And this is really what we call consensus. So there's really two processes that go on to achieve consensus. The first process is what we call consistency. So in all of the nodes, have they seen the same data? And once they've seen the same data, they still aren't necessarily in consensus given current popularized consensus mechanisms. So both proof of work and proof of stake have this property wherein once we've seen the same blocks, we still might not agree. And in the Bitcoin context, it manifests as an orphan block. Those don't happen very often, so we're not really in disagreement very often, but they still do indeed take place. So we can't say that we've reached consensus until we're some depth away from the transaction. And once that transaction's deep enough, we can say, okay, 51% of the network has indeed voted for this based off the statistical sample of blocks that are built on top of it. Ergo, we can say that transaction is finalized. So over time, we have a statistical guarantee of coming to consensus, but it happens much later than consistency. So, again, just using, Bitcoin as the archetype, because it is the archetype for all proof of work systems. When you see two blocks and they're a fork and you have block A and B, technically when we've seen both blocks, we're consistent. But we don't know what consensus is because you might be operating on A, I might be operating on B, and there isn't agreement on what the canonical tip of the chain is, nor what the canonical sort of state there of the, transaction ledger is. So that's the example of why it takes time, and that time typically, if you think about the statistics of it, it's at least 6 blocks to get to that statistical consensus. So, what that does, depending on the system and depending on that delta between when you become consistent and when you reach consensus, is it limits how quickly you can then talk to a different shard, right? So if we think about let's say the Ethereum model in this example, they have what functionally feels a lot like shards because they have an L1, L2 sort of scaling strategy. And if you look at the time that they take between when you can clear funds from the L1 to the L2 or the L2 back to the L1, those clearance times are potentially very long, right? So if you go, over to Arbitrum, right, coming back, you have like this very long clearing period to get back to, the main chain. And the reason for that is because of this like need when I go across shard that I like must absolutely know that I'm in consensus before I go to a different shard. Because if I go and then the consensus changes in the origin, like I'm screwed because there's no way to then reconcile these systems because they're only loosely connected. Because Ethereum has no respect for Arbitrum. Arbitrum kind of like exists independent of Ethereum. So if some like problem happens in Arbitrum, Ethereum's just like, I'm going to keep chugging along. And like Ethereum's kind of like, or Arbitrum's like up a creek basically because like it had a sort of divergence in consensus and Ethereum like keeps going. And so now you have sort of like an irreconcilable state problem. So then what you must do is you must guarantee that there will never be a change before you leave the shard. If we think about Arbitrum as a shard. So that's like the challenge is that because it takes time and then you have to wait like a time much longer than that time to sort of guarantee that won't reverse. You can't do these like cross shard referencing things quickly, or you can't reference from an L1 to an L2 quickly. What we do within Quai is we have a hierarchy of chains, and you can kind of think of it like an L1, L2, L3, like all integrated together, but they're all mutually verifying each other. So, and again, in this example, we have, the prime region and zone chain. So if we think about the prime chain as like Ethereum, and we think about the zone chain as Arbitrum, any prime block is only valid if the region and zone block are also valid. So the prime chain is saying, I implicitly respect the rules of all of the chains below me. And if those rules are violated, I am no longer valid. So you could think about that as like, some form of like a based, verified roll-up. But we basically constructed that into the system. And so what that allows us to do is there's sort of two properties that are introduced. One is that concept of reciprocal validation. And the other concept is the consensus that we've come up with Poem immediately follows consistency. So we don't have a statistical guarantee over time of being in consensus after consistency. We are instantaneously in consensus immediately with consistency. So the only limitation on our system is that the data has to propagate. We don't have to wait long periods of time between referencing between the shards. We just have to get propagation of data. And so what that allows you to do is it allows you to create the system that can have effectively an unbounded number of shards, which allows you to scale really without, practical bound, except for that one property we talked about, which is intershard
communication.
Intershard respending time would be like the thing that's the sacrifice. But you can just keep adding new shards completely orthogonal to the process going on in any single shard.
So there's no theoretical limit. It's just that the respend time, the more shards you have, the longer it's going to take for that communication to propagate to have the respendability.
Yeah, well, and that is a true statement. And the other thing, actually, based off, if you just try to like project out like what the limit is, I don't think it's actually the system. I think it's the size of the planet. So like based off the number of people and like the carrying capacity of Earth and like what economic transactions look like, being able to shard to the degree that we can shard and scale to the degree that we can shard, your limit isn't going to be, can that system handle the transaction? It's going to be, you don't have enough people to make enough transactions to saturate the system.
What is this idea of, can you explain the concept of multi-threaded execution in blockchain terms? And, how does this differ from single-threaded execution?
Right. So in some ways, so what is multi-threaded execution? So in a blockchain, in a sharded blockchain, you can think about each chain as an independent process or thread. And when you're running threads, there's still like a coordinating process where you have to sort of get jobs or present results so that like you can make sort of cooperative process, going forward. So in programming, right, when you have threads, you create like a certain number of threads, and then you create like a batch of jobs, and as those threads complete, they sort of write back to sort of the hypervisor that's distributing the jobs and updating these like more global states. So you can kind of think of in the system, the zones are like threads, and the region and prime are like the hypervisor processes that are dispatching the jobs and then recording the state updates that need to be recorded for the other threads in a sort of atomic sequenced process. So you can kind of think of like prime and region as like the hypervisor process. The cool part is that the mechanism by which they do that is the same process by which the zones move forward. So you don't have like multiple versions of consensus. Everyone's just trying to mine the longest chain. It's just this nice statistical outcome that we also produce region and prime blocks, which we can use to then sequence together all of the zones. So in some ways, this isn't like many blockchains. You can actually think about this as one blockchain, but each one of the zone chains has a privileged execution access to a sub tree of the state root, which is the sharding of the address space. So there's technically only one root in the system, which is the universal address space, but each shard can only write to part of the address space. So in like the 0,0 shard, it's writing to like the 0,0 address space. The 0,1 is writing to the 0,1 address space, but the actual system itself is actually generating a unified state tree. It's just who gets to update what part of the state. And I know I'm getting super wonky right now.
Yeah, we're getting into the weeds a little bit, but it's interesting it's obviously you've thought through this on a lot of different game theoretical levels. This has obviously been a challenge for a long time to look at different, because usually with the blockchain trilemma, right, there's trade-offs, right? If you optimize for security and, privacy, security and what's the other one? Security and I'm blocking on right now.
So in terms of the trilemma, right? I believe
there's scalability, security, and
so scalability, security, and decentralization.
There you go.
I believe is how it was proposed.
So like Bitcoin's optimized for security and decentralization, but scalability obviously is not the case.
So I would be a little bit careful with that like assessment. I think that's a very
that is the consensus position right now. The majority, like Bitcoin is optimized for security and decentralization, and at the expense of scalability. So are you saying that you reject that? Which is fine.
I would be careful on the model. So I believe the trilemma as proposed by Vitalik is somewhat of a sophomoric attempt at describing a complex problem.
Okay, I see what you're saying.
But it's not
the whole picture. But
it's not what you would classically refer to as like a true engineering trade-off graph. And these like exist in engineering.
Yeah.
But in engineering, when you create one of these things, there's units assigned, and like the units make sense like for the thing that you're drawing. But like, what is the unit of decentralization? What is the unit of security? Like in this graph, like I don't even know how to define those units, let alone measure them. So like until you get like a unitable definition of the points of the triangle, it's just a subjective approximation of the problem. It's not a real like thing, right? So like when we're talking about systems, I think CAP theorem is like more appropriate because like you can actually put units on CAP theorem, which is a theorem about databases and how databases work and scale. So I think CAP theorem is like a more appropriate trade-off space, and it operates as a triangle. And I actually believe what we've done is we've said we figured out how to extend CAP theorem into another dimension, which introduces consensus as one of the points. So it's actually like a tetrahedron, and I believe that is the trade-off space from like an engineering physics perspective of what you can do in blockchains. I think that the trilemma is inadequate to like fully express what the real trade-off field is.
Interesting. We're pushing the boundaries of all of this right now, of thought around it, and I guess I want to say research, but that's not the right term. But just, I guess, as a thought experiment, right? These different levers that you can kind of pull on. Most people that are in Web3 are familiar with the blockchain trilemma, but what you're describing is taking it a step further intellectually to unpack the next dimension of it.
It's like it's like an engineering formalization, and even in what we're doing, and to go back to the question of like why hasn't it been done before? I think it's because nobody was this crazy as I was, to be like perfectly frank. Spending this much time building a system in blockchain, there's very few people that would be willing to do it, especially not knowing that you could get to a result. For this system to have worked, right, it started sort of as an engineering problem of, okay, we can shard, we can subnet, we can use merge mining to shard state without sharding work. But we didn't actually know what the consensus mechanism really was going to be. We had this concept of like, we called it the hierarchical longest chain rule, but it was actually fundamentally deficient for getting the system to resolve. And we didn't actually come up with POEM until like 5 years in, but like POEM is like a requirement. If you don't have POEM, like this system doesn't really work, but we just had faith that like we could eventually get there. And then we like ran ourselves into a corner, and then I had to come up with a solution. And the solution was like on the head of a pin, which is you have to create a consensus mechanism that has the property of causal invariance. And with that, you can then accomplish what you're trying to do with sharding with no bound, basically. But you need that very specific property to get there. And we didn't even know, one, that we needed the property, or two, that it was even possible, and three, that it was possible within a dominant strategy incentive compatible way until like 5 years in. So like that's why like no one's really solved the problem. I'll also say there's different types of formalisms that like exist, and there's different types of people that come from different backgrounds that like work on these problems. So the other reason I think this wasn't done is because one of these sort of fields that has like come into blockchain in a more rigorous way, right, are these like, these information theory guys, right, or information science, whatever you want to call it. But they've dabbled into consensus. And one of the primary mechanisms by what they assess if a consensus is secure or not is called the backbone model. So it's this concept of, and it's been applied. It was like the first sort of formal proof that like Bitcoin can kind of work. And it was actually written in 2014 by Gray out of Texas A&M. But that model uses the concept of rounds and uses the concept of time. And if you're using a work-based process with a causally invariant consensus mechanism, a choice of how the blocks go in order effectively or priority, that is a time invariant process. When I say causally invariant, it also means time invariant. And so one of the reasons you can't see it is because the model by which you're thinking and assessing is time-based. So only if you can like transcend the concept of time can you see the solution.
Interesting.
And the thing is, I wasn't like looking for...
What does that mean, causal invariance, time invariance? Can you define those terms?
So what it means is if you see a block, no matter when you see it, if it's today, tomorrow, 10 seconds ago, you will measure and assess that block the same. And given the same set of blocks, you will make the same choice about that block. So it doesn't matter when you get it, you'll still make the same choice.
Oh, okay.
So that's the property by which consensus becomes a necessary is necessarily had when consistency is reached. So in some ways, it's like if we go back to the fork example and we talk about blocks A and B, right? With the heaviest chain rule, you see A first, you pick A. I see B first, I pick B. So we're consistent because then you see B and I see A, but like I'm still going to pick B, you're still going to pick A, and we don't have a resolution to be had here. But with POEM, we will both pick one of those blocks because one of those blocks is better. Yeah. And one of those blocks will, when we work on it, increase our expected revenue.
Gotcha.
Right. So the fact that you see A first doesn't matter, because if B is a heavier block, when you see B, you will pick B. And then when I see A, I'm going to compare them and I'm going to say, okay, I'm still picking B. So now, without us having to talk, without us having to do rounds, we've come up with a mechanism that guarantees deterministically we'll always make the same choice, given the same data, regardless in what order they arrive or when they arrive. And that is like this very special property. And without that property, which technically like violates the model by which you assess security of, this backbone model, you can't actually come to a solution that like solves unbounded sharding. And this is actually such a fundamental thing. It's why we have Stephen Wolfram as an advisor. So for people that don't know who Stephen Wolfram is, he's like this smart physicist guy that is
Wolfram
this
Alpha.
CEO of Wolfram Alpha,
the video,
the maker of Mathematica. And right, he, has a degree in physics. He's worked in software like all his life, and he's also, dabbled in physics. And he has these concepts of, cellular automata, and sort of observing those, he started to understand that there's this property of physics where you could potentially create highly complex emergent outcome and rules from like a very simple set of rules, basically. And this manifested in what is called the Wolfram Physics Project. So in 2020, he kind of like publicly announced that he was like working on this idea of how to create a grand unified theory of physics from this like simple set of rules. And the sort of definition of the thing that creates the complexities of what he believes all physics to be is what would be called a causally invariant multi-way graph bounded by a computationally irreducible process. So in that statement, that is like the definition of how he thinks the entirety of the world works. And from that,
interesting,
you can derive all like rules of physics. Like, so you can get special relativity from that statement. You can get quantum mechanics from that statement. Okay.
Where does this stand right now for actually proving this? I mean, I know the grand unified theory is kind of like the holy grail of physics, right?
Yeah, I mean, there's a number of people that have like a number of different theories, and he has shown some things, and like there's promising areas. I don't think you can say he's come up with something different that has been experimentally verifiable, but he's also kind of having to rebuild all of physics from like zero, because he's starting from a completely different point than anyone else started from. Now, the interesting part about this is, so I have a background in material science. Like, I have some physics training. I'm not like a theoretical physicist, but I pay attention to this stuff.
Yeah.
And I knew about the Wolfram Physics Project. And the interesting thing is, once I came up with Poem, I started to internalize that I just created something that's causally invariant. And then when I looked, I was like, oh, and it's also a multi-way graph. And through the process of mining, it's progressing through a computationally irreducible process. So what I had seen is that we had a perfectly analogous system to his fundamental theory of physics. So we reached out, and I was like, hey, you might be interested in this. And, we talked, and he became an advisor of the project. We've actually had 10 hours of podcasts together, talking about Quai with Poem, Quai and She, how this is very analogous to sort of his fundamental theory of physics.
Is he mining Quai right now? That's all I want to know.
I think within his organization, he potentially is.
He's mining a little Quai?
Yeah.
That's pretty cool.
Well, and so I mentioned Steph McCurdy, like he's a person in the org, and there's a couple other people in his organization that are looking at Quai. And one of the things that, he thinks is also very valuable about it is Chi, because what Chi really does is it ties money back to physics.
Yeah.
So if you can relate Chi, as we said, to electricity costs, we're not actually saying it's really electricity costs. There's there's a little bit of a nuance within physics, which is it's not just about energy expenditure, it's actually about useful energy expenditure. And the measurement of that useful energy expenditure is really entropy. So when we say poem, proof of entropy minima, we're saying we are trying to decrease the disorder to the greatest degree within the system. And that is the measurement which poem is making, but it's the most direct measurement of the useful energy that's going into mining. And so if we talk about like humans and human well-being, it's not about the energy expenditure, it's about the useful energy expenditure to like make like this table. So like this table has this order, but it's like useful order as a table. But if I'm like to shatter this table, I haven't, from a molecular standpoint, million X the entropy, but as a table, it's no longer useful, right? So it's not just the order, but it's useful ordering that like becomes important to human well-being. But the cool part is with poem, you're directly measuring useful ordering, and then you're tokenizing it into money. And so now money is becoming a reflection of the thing which represents human well-being. So instead of money being political, money being manipulatable, you're saying money is the representation of tokenized human well-being, and then that becomes the reward function in the system, which is like a pretty cool statement. But from that statement, you're also starting to delve into this whole other field that's called thermoeconomics. So in economics, there's what we call microeconomics and macroeconomics. Microeconomics is the economic form and outcome of constrained systems that you can get from game theory. So like everything in microeconomics that is like largely true and it's largely provable about like
supply and demand and
what happens and maximizing aggregate economic surplus where supply meets demand, et cetera, et cetera. Those are all things that are like true. Macroeconomics, on the other hand, is Keynesian state propaganda to justify the central bank and allow politicians to arbitrarily, print money. Like it's not a real thing.
Now, I don't disagree with you. That's why I'm laughing.
But
as an Austrian economist myself,
I think a lot of people.
I mean, I don't think everything is wrong, but I think largely the premise of just printing money to have animal spirits, and
I think. I don't
using
know.
Communist theory to control the money supply, like a communist board to decide interest rates. I mean, there's so many things that are just, I think are ridiculous.
I think you're trying to be generous. I don't know if you could actually state what part of macro you think is correct.
Well, when you print, I mean, there are things that are somewhat true. I mean, it's like when you take drugs, you feel good for a little while, right? Before you have to deal with the side effects. So, yes, by changing the, fundamental, by making money essentially inflate and rob you of your purchasing power, you are encouraging people not to want to spend that money. Like there is something there that's
okay.
Like,
So
you're kind of degrading society. You're basically like, but to print a bunch of money and spend it, yes, in the short term it can have these kind of like drug high effects,
drug
right?
effects, yeah.
Yeah, so I think there's something there, like some of it.
So some like very small sort of conclusions or pieces of macro you could be sympathetic to.
Exactly. That's my point.
That's fine.
I think also that Keynes had a pretty good idea with the Bancor to try to like when he wanted, what was it called? Bretton Woods, right? Like he didn't want it to be any individual, country to have, the ability to print money. He kind of wanted to have it tied back to a basket of, real world things, I think, so there were some interesting good ideas there, I thought, but, largely, I think.
Well, so yeah. And that's really what you're trying to do with Chi effectively. So like if we look at, competitive commodity goods, and you look at the pricing of a competitive commodity good, that price should largely be a reflection of the total energy that went into producing it.
Interesting, yeah. It's an interesting thought.
Right.
It is true. I mean, yeah.
If you can then tokenize that and then like have that unit, it's actually a very good natural unit of account. So when we're talking about we want to have money that's tied to real world things, but we want to do it in a way such that nobody controls it and there isn't sort of custodial risk or political risk. energy becomes this interesting phenomena that
Yeah.
we can use in this decentralized way via the work-based process to get a measurement on that thing to create a representation. And that's really like what Qi is doing. And so in some ways, I actually think that, and I mean this in like a very nuanced technical way, that Qi is a better analogy to digital gold than Bitcoin. Now, I'm not saying that like Qi, because Qi is meant to have stable purchasing power, Bitcoin is not. But if you're actually trying to draw the analogy out, it's a better analog to digital gold than Bitcoin. And the reason is this. When we look at gold, the reason that it was useful, besides, the other characteristics of money, durability, blah, 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 is because gold was via the process of supernovas roughly evenly distributed throughout the Earth's crust. So that meant that no matter when somebody existed and what time they existed in or where they existed, they had to roughly expend the same amount of energy to find, mine, and refine gold.
There's also stock to flow. That's a big part of it, which I don't know if that applies to Qi because there's other there's other physical commodities like silver and copper and, that can be much more responsive to, supply and demand, where I feel like isn't Qi responsive to those metrics where the issuance and the inflation and the deflation, like that can change much more rapidly than gold. Gold is, the stock to flow of gold is set pretty arbitrarily, roughly through human history forever. It's always been 1% to 3%. It doesn't really have, this ability to, if there's a huge demand for it, the supply can't expand by 20% a year.
No,
that's a fact. I mean, that's why gold, that's why there are other metals that are rarer than gold, like I think platinum technically, but like platinum supply can be inflated pretty rapidly.
No, I mean, if
stock to flow wise,
if you tripled,
that stock to flow.
if you tripled the price of gold, that would be enough encouragement investment that maybe not instantaneously.
You wouldn't be able to do it like you would with copper or with silver, and that's historically why it's been the best kind of money, because no matter what the demand is, there's been this constraint on it where you can't blow out the supply significantly. You can't rapidly increase the production, the supply, the inflation rate essentially. Gold has historically been 1% to 3%. Even during the gold rush, I think it was like 4%.
I think what,
whereas like silver, you can increase the supply by like 30% in a year. Like if it was, they did this with copper, they did this with other metals, but gold historically has resisted that. It's always been more scarce. It's been harder to do that too. I think that's one of the stock to flow aspect is a major part of why gold has been this way.
I would potentially make the argument that that's more of a supply side phenomena related to the monetary nature of gold that is not true for something like silver. We don't necessarily need to go down this rabbit hole. The point that I do want to make about gold, though, is that it, at any given point in time, is roughly representative of the energy that goes into producing 1 ounce. However we get there, like that's what ends up happening. So when we think about gold, it's just a representation of energy. And it's like a consistent representation of energy over time. And that also then manifests as sort of like consistent purchasing power over hundreds of years, right?
Mm.
So, people look at gold and go back like 200 years and they'll be like, for 1 ounce, you could get a fine wool tailored custom suit.
Mm-hmm.
And then like today,
it still buys you.
it still gets me a suit. So like within like a factor, its purchasing power is consistent. And the reason it's consistent is because gold is pretty much a representation of energy of producing that piece of gold. And since the other goods are also that on a commodity basis, then gold keeps purchasing power. So the concept with Qi then is it's meant to also have that property where its value based off the market design is always convergent to its production cost. So it's not meant to like go up in time like with network value. It's always just meant to buy you the same shit today and tomorrow as it did yesterday. Like that's like the design phenomenon. But the reason it has that property is because it's meant to converge to the cost of production, i.e. the energy that went into producing it. And so in that way, I think it's a good representation of gold. If you look at Bitcoin actually has better like hoarding characteristics
it's
than gold,
more,
right?
over time, it gets more and more.
When they like issued notes,
it's the,
like paper notes on gold, it was like $200 an ounce, and now it's like 3,000. So we did 15x in 25 years. Bitcoin has obviously done way better than that.
But Bitcoin is also, gold's been around for millennia, right? Bitcoin is like this new 10 to 20 year old project that has been the best performing asset in all of human history, but is also still we're still in an early adoption phase of that S curve. I mean, it's still being priced mathematically into the market. Like, what is the value of an absolutely scarce digital asset? Like, that's
but I'm saying the scarcity curve is a little bit different. It's superior to the scarcity curve on gold.
The stock to flow is now, I believe, under gold's historic stock to flow of 2%. I think we're at 1.5% for Bitcoin.
Which is my point, is that it actually has a characteristic that makes it want to deflate faster and have a better like. Bitcoin isn't meant to be like fixed purchasing power. Bitcoin is designed.
It doesn't seem that way.
It's designed to go up in purchasing power over time.
Yeah.
Like it's a different design mechanism, right? If you said you wanted to make Bitcoin where it just like maintained purchasing power, you wouldn't have a fixed arbitrary emissions. You would emit it relative to the energy that went in, roughly speaking, the hash on like a short time frame. So you'd emit it relative to the hashes going to the block. That would be like the energetic representation. But it was specifically designed to be better than that in terms of its like flow.
Yeah.
Right.
Stock to flow. I think that's the key.
Yeah. It was purposely designed to create greater scarcity than gold and the energy that went into it. So because of that, if we were to like look at the Bitcoin supply and say, what is the current market cap? It isn't a measure of the aggregate energy that went into it. It's specifically designed to be way higher than that. But that's why I say in this analogy, technically issuing something proportional to hash is more of a digital gold than Bitcoin, because Bitcoin is actually meant to be superior to that. But in doing that, it gives that hoarded characteristic. Whereas if you want something to circulate, it's much easier to get it to circulate in a system where you don't have like extraordinarily high future expected values. You have consistent purchasing power expectations.
Yeah. I don't know how that changes as, again, these are all super interesting technological experiments and monetary experiments. And I'm fascinated by all this. And, 10, 20, 30 years from now, I don't know what the situation is going to be. I don't know, Bitcoin's volatility is going down over time. The question is, where will we be in what will that look like under, say, a more mass adoption? I don't know. Right. And
but like, as you say, it's actually below gold.
Yeah.
So like if everything sort of keeps continuing without shocks, it's going to continue to do better than gold.
Oh, I think that's hands down, absolutely.
Yeah. Right. But
it's anyway, engineered money better than gold for that exact price.
I wouldn't say it's money. It's a store of value. It's not meant to be money. It's meant to be something different than money, right?
I think it can be like this kind of sound money, this kind of it has monetary properties for sure. It's definitely a store of value. But I would say that it is sound money. It's a form of sound money. You can use it as money. Like there are, other things that have monetary characteristics that can be used as money. I don't think that there's only needs to be one money, right? Like I think competition, different types of money, I think it's all good things. I think, competition is good. I'm a libertarian at heart, I'm a techno optimist. I think different strokes for different folks, and things can be used for different purposes, right? Like I use dollars for things, and then I have my Bitcoin, and I rarely spend Bitcoin, but at some point in the future, I may be willing to spend my Bitcoin, right, for certain things, and I also have Quai, and I have different assets in Ethereum. It's I participate in these different communities, but what I'm like, I think of Bitcoin as more of like a savings account, like slash money, right? Sound money, you know what I mean? That's the way I personally think about it.
I'm saying that it's sounder than gold, but because of that,
Gresham's law,
it's Gresham's law, which is like it doesn't want to circulate, right? So like the point of Qi is to like create a circulating unit, which is not the point of Bitcoin in some ways. Like it's designed not to circulate. It's designed to be hoarded. It's designed to be hoarded more than gold.
I don't know if it was designed that way. I mean, peer-to-peer electronic cash was the original white paper, but I think at the end of the day, the fundamentals are going to decide what's
going on.
It doesn't really matter what fucking people think or what they want. I mean, the fundamentals of the actual asset itself are going to kind of dictate the incentive structure and the behavior, right?
It's a hoarded quantity.
Yeah.
So the point of chi is to make something that you obviously has more purchasing power stability that creates that unit of account that's independent of fiat, so you can fully decouple and delink. But when you decouple from the dollar, the politics, and the fiat, what you're actually coupling to is the physics. And that creates this new field of economics, potentially called thermoeconomics.
I know, I think it's really cool, thermoeconomics. I like that term. I think that should be a title of this episode. Scaling in thermoeconomics. You hear me, Paul?
which is also one of the things that Wolfram is very interested in, because no one has created a good description of macroeconomics. But thermoeconomics, using the physics of representative energy flows as a mechanism for designing or understanding a macroeconomic environment, is incredibly interesting, and it's probably the path at which you can define rational, physics-based macroeconomic system.
I think you're right.
And one of the fundamental units and tools to do that is something that's like energy-based money. And so he's also interested in it because of the potential implications of having energy-based money. And we're not the first ones to sort of come up with this concept. Henry Ford proposed this, Thomas Edison proposed this, Buckminster Fuller proposed this. It's just nobody had the tools to realize it until now. And Bitcoin was one of the big steps to getting there. But when we look at Bitcoin, right, Bitcoin's value is meant to not be the representation of energy. It's purposely designed to be the representation of future expected value. It's supposed to have speculative nature, and it's supposed to be influenced by stock to flow. It's not designed to reflect
energy, definitely
the kilowatts that went into it.
I don't know.
It's
energy
designed to
plays a part in that equation. I think
it absolutely does.
It's definitely thermoeconomics at play there.
It's work based, but it's a convolution of those factors. So when we look at Bitcoin and we look at the total amount of Bitcoin, it far exceeds the energy that's been expended into it from mining. So the market cap of Bitcoin in no way reflects one-to-one, not even close, the total energy that went into mining. And it's like 10, 20, 50x that.
What you're saying is that, the value of Bitcoin is worth 50x the energy that went into. That's what you're saying. Okay.
Yes, and it's through the design of the emissions curve, and it's through the design of the stock to flow. It's through the design of the network effect.
Part of that, for sure.
Is like what gets you that price premium, and that's fine. In the design.
There's definite thermoeconomics involved in the right now deploying miners and energy and hash rate and kind of calculating, okay, what's my cost of production and what is the revenue.
Correct. On the instantaneous basis, it's accurate. But on an aggregate basis, it is meant to be highly divergent.
Historically, if you are a producer of Bitcoin, like if you're a miner, you have real world energy costs that you have to pay. So you can't. It's not like you can really just sit on all of that Bitcoin. Like you have to cover your real world costs, right? You're a producer, right? Which is interesting because there is that real world cost there. But yes, if you hold Bitcoin, that you mine for a long time, then obviously it's the best performing asset in all of human history.
Right.
Of course, it exceeds the energy. 50x is it might even be more than that, right? But on a short term basis, no. There are real thermoeconomics at play there.
Instantaneously, but it's designed to significantly diverge such that the market cap will always be much superior to the energy that went into producing it by design.
That's what we predict, right? That's obviously anything can happen in the future, but as of right now, for sure. And Quai could have the similar dynamic at play eventually, right?
The Quai token is maybe not trying to perfectly replicate Bitcoin because of
I would say the same is true for Ethereum too. When they were, the mining that went into it is greatly, it's worth the value of the protocol and the network and the Ethereum market cap is worth greatly what the energy that went into it.
Right. So Quai is also designed to be divergent in that way. It's meant to represent many times the energy that goes into it. But Chi is not. Chi is meant to directly represent at all times the total aggregate energy that went into Chi, which allows it to become this unit of account, which allows it to become the basis of thermoeconomics, because the unit which it is representing is entropy, which is the unit of physics of useful things that dictate commodities and human well-being.
Thinking of Chi, I think of it, with the fact that the issuance and the can change so drastically to kind of keep pace with that. I think of it like almost like, digital oil, that's the way I think about it, because like the inflation rate of Quai can change, or Chi can change quickly. It can react quickly. Something like gold really can't that well. It can't respond to that.
Yeah, it's
I would think more of like digital oil. That's kind of the analogy that I think, thinking of Chi, because it's related to energy, and it's like oil's the same way.
Well,
if the cost of product goes up, it can change, right? But that,
I would actually say digital dollars.
What do you mean digital dollars?
Well, because like dollars are designed to create like purchasing price stability.
Well,
with
kind
time.
of. Yeah.
It drifts.
Yeah,
like
drifts,
it always drifts down.
It's drifting down.
It's always drifting down, but on a given year,
it's funny with the petrodollar too. I mean, I think that once Nixon took us off the gold standard, I mean, they kind of knew intuitively, like, this shit, we got to do something immediately here to kind of like attach to something, even if it's not quite a firm attachment. We got to have some
like a psychological attachment,
kind of like psychological attachment, right, for energy. Right?
Well, and with the petrodollar under Greenspan, it became the gold dollar.
Yeah.
Really. So like if you read Greenspan and like what he said, like basically the way he did well was always thinking about the dollar relative to gold. So like he was actually trying to run rates so that the dollar didn't diverge from gold, and then they kind of lost the ability to do that, and that's when they actually approved gold ETFs.
Yeah, you told me that, the
right?
BMA and all that.
Yeah. So then there's like a whole set of like how you were able to hypothecate paper gold to like cover up the fact that the dollar was highly divergent, and et cetera, et cetera.
Oh my God. So many schemes. Humans will always try to scheme if they can.
Let the money guys figure out how to scheme. They figure out a lot of schemes, man.
Yep. That's why we trust the mathematics behind these blockchains, where you set it up, and there's no human that's like changing things and like doing all this stuff. You know what I mean? It's not decided by some human based on his whims or how he feels or what's, you know what I mean? Like it's math. It's like Vera said numerous is the quote, like faith in mathematics, right? Faith in physics, right?
Yeah. So that's like the thing. So like when we look at the fact that even Bitcoiners end up using USDT or USDC, from a decentralization perspective and in like a fiat delinkings perspective, that's like highly problematic to me. And so the proposal is, if you construct Chi, which again is proof of work based, it's related to physics, but ideally it creates an endogenous stable-like thing. It can act as a replacement for dollars.
Yeah, I think
it's not trying to act as a replacement for Bitcoin. It's trying to act as a replacement for dollars.
There's a huge market for that.
Right.
And that's why the algorithmic stablecoin thing is so popular, because people are like, I don't want to have to fucking deal with going back to a bank. I don't want to have to, deal with permission money. Like I don't want to worry that my, stablecoin asset's going to get frozen because, 3 years ago, a criminal transacted it through a wallet, right? And now it's, it made its way to an exchange, and I was paid for it by some, farmer who, bought, a car off me or something. You know what I mean? So, I think that, something like Chi, if it works and if it plays out over time, I think is going to be fascinating, because it kind of like I want to say die, but not quite like die. But just the idea of the idea that it's not a reserve-backed representation of value, and it can withstand. It's not something like Terra Luna where it's like a Ponzi scheme. It's something tied to something real.
Well,
right?
Going back to your physics reference, is it's trying to use an objective, physically measured, competitive process of mining
exactly
to create something that roughly facsimulates a basket of goods.
Yeah.
Right. So you're trying to get this purchasing power parity without having to inject oracleization, centralization, or politics, but rather like over leverage the proof of work process as an oracleization mechanism to produce the stability.
It's fascinating.
Right. And so that's like a really cool property. But circling back to why was this so hard, and nobody's done this before, you literally had to come up with something that was convergent in almost perfect analogy to a grand unified theory of physics to actually fundamentally figure out how to scale distributed trustless systems.
Fascinating. Let's diverge to another topic real quickly as we wrap up this episode. Let's talk a little bit about composability, because one thing I'm interested in is like DeFi, right? So decentralized finance built on a smart contract blockchain. DeFi usually relies heavily on composability between protocols. How does Quai ensure that applications can seamlessly interact across different shards and potentially other chains? Like, what is your plan there to connect I know you mentioned you're EVM compatible.
Yeah.
Talk me through all this.
Yeah. So, in terms of the composability cross shard, it's perfectly composable. So we are technically like EVM plus. So there's effectively 2 opcodes that we had to add to the EVM to sort of make contracting cross shard compatible. And when you deploy a contract, right now we're still, in a single shard setting because we haven't like hit that 600, 700 TPS that will cause 2 shards to happen. When that does happen, what you can do is you can deploy what is like a sister contract into the second shard, which is like a copy of your first contract. It just says this is also sort of like a valid state contract that we manage together. So if you want to do like an ERC20, you basically just deploy copies of your ERC20 contract into all of the shards, and then when people transfer, they can exist seamlessly amongst all the shards, and all you're doing is deploying an extra copy and basically then specifying the canonical copy in all the other places. So that's how it sort of links the system together. But in terms of cross-shard interaction, if I start a transaction in one of these instances of the copy, it will actually emit what we call an ETX, or an external transaction. And when that lands in the destination, that can have data that then plays in the destination execution smart contract. So they're technically perfectly composable and interoperable, and you can actually cascade as much complexity across the shards as you want. The only thing that's going to happen here is there's going to be delays to finishing the execution path based off how long it takes the shards to reference, but it's completely composable across shards. So, initially, if you want to do EVM deployments, just like fork whatever you want because you're only deploying it in one shard anyway. Once you get to 2 shards, there's a slight overhead of complexity where you have to create the sister contracts and you have to add into the registry, who you're talking to.
So this doesn't happen naturally. Developers would have to do this as if a new shard, say we hit 700 TPS, a new shard gets created. Do developers have to deploy another contract on the next shard, or does it just happen naturally?
No, they would have to deploy it.
They would. Okay, so
they would have to deploy it. And we've given examples of like how you do this for archetypical contracts. So if like you want to do an ERC20, like do your ERC20 and then also deploy your sister, but you should already be set up to do it when you deploy your first one. So if you're a forward-thinking developer, you're going to use one of like our slightly modified examples so that when we get to the second shard, you're perfectly compatible. If you don't do that, you're going to have a slightly harder migration time. And if you're in a competitive space, you might lose business because you're not ready for the second shard. But if you are, you just like deploy the sister contract when it goes live, and then like Bob's your uncle.
Gotcha. Interesting. What about composability between different blockchains, like not Quai, like with Ethereum, with say Bitcoin even? Like, is there any possibility there?
Yeah. So we had a bridge. Unfortunately, the bridge was Entangle, and Entangle recently closed up shop.
Really? What happened with Tangle? Tangled in some drama or what?
Yeah, there's some drama. There was like a hack of some sort. They like ran out of funding, and then they like, decided to close up shop. So in the process of getting another bridge integrated that will connect us to all the other EVM chains. And so that's something people will be able to use. The other one that's interesting is we have a partnership with Portal to Bitcoin. They still haven't gone live yet, but ideally that will link us to Bitcoin.
Oh, really cool.
Yeah.
That's very cool.
Yeah. And I think it would be cool there because there's potential ways where you could use your Bitcoin to like look at yield. But there's also ways in which you can potentially hedge risk with Qi. So, I think there's like some complementary, pieces that you can't get with just within the Bitcoin ecosystem that you could get once Portal to Bitcoin finally goes mainnet. So
fascinating. I guess we can wrap with this final question. Real world applications. Given Quai scaling abilities, what types of applications become possible that simply wouldn't work on existing blockchains?
Right. So the thing that I've always been using as the design criteria for the system is Visa MasterCard. So everything about the system is how do you create a decentralized system, proof of work based, like Bitcoin, having those same type of properties, but to do it going to scale of Visa or MasterCard. So that's not just a throughput number, that's also a settlement time number. So when you go to a terminal and you tap to pay or chip your card, it's about 8 seconds in totality on average to get that acceptance response back.
Mhm.
So that was the design criteria for the system. So like very specifically, this whole system was designed to go after transactional money. And then the reason you have something like Qi is so you have that decentralized system that has the independent unit of account that's not linked to fiat, not via algorithmic stables, not via custodial stables, but just has a separate referential value so you can decouple completely from the dollar, ideally. And so that's like why we put Qi into the system as well. So like you're going after the transactional use of crypto. That is like the point. In terms of the applications that you can build, there's additional applications that like come into play because the sort of time is very, very fast. And some of these applications have been explored by the not so decentralized proof of stake systems with, dozen validator type.
Like Solana, for example.
Yeah. Like Solana, where you do sort of just like real time things like, pump.fun, where it's effectively some type of gambling type game.
Yeah.
If we're honest with each other.
I mean, that's what it is. I mean, as long as you know going into it that it's like, that's what it is. I mean,
like
people have been gambling since the dawn of humanity. I mean, they found dice and bones in caves that fucking cavemen were throwing around. I mean, it's just part of the fun of being human, right?
Yeah.
So it's part of the human experience. Like that's just not going to change. It's just part of markets. It's part of fun. So
yeah. So 100% as a libertarian, like you do you. I think as long as everyone's like above board with disclosures and like what it is, like as long as you're walking into a casino.
I think everybody knows. I think they just, people just like to cry when
they like to cry. They'll be like, oh,
I bought fucking grandma's ass coin, and I'm so sad. It went to zero.
I kind of think there's like very few people.
Or Haktua, that was a hilarious one,
right? There's very few people who are actually like legitimately unknowing to what game they're playing.
They're happy when they win. They like to cry when they lose. So
and I have very little respect for the people that like cry and know that like it's a gambling situation.
Yeah,
just like, oh my god, I didn't know. Like, shut the fuck up.
Shut the fuck up.
Like, what are you talking about?
What are you talking about? Yeah, come on. The whole thing is ridiculous. I don't.
So there's stuff that you can do like that. On Quai, there's a meme coin launchpad. It's called poop.fun. I love the name just because it is fully embracing what it is.
Yeah.
And there's some like unique features about how they launch and they compete, and you get better Gini coefficients and distributions and things. So in that like sort of like bracketed competition system, like recently went live. So it's an interesting improvement over the meme coin launch model. But there's other applications too, and it's really like there's no limit to what you can do once you have like decentralized, permissionless, censorship-resistant money.
Yeah.
One other application that's built and being used is Kipper Money, which is basically it's a browser extension that allows you to tip people on X. Like Nostr has, features like this, Zaps.
You can send sats and whatnot.
You can send sats. But the idea here is instead of having to create a new social network that is like an isolated subset of people, you basically just download a browser extension and it works on the existing social networks.
Yeah.
But it allows you to tip anybody in that system. And it's a pretty cool system because it basically, as an extension, it sort of modifies your view. So it looks like you just have new features to X. So like you just have this cool tipping button, and when you hit it, like it allows you to tip somebody. If you like somebody, you can actually set it so like likes pay people. And because Quai is low cost and relatively real time, you can like hit a like and it tips them a Quai, and you can then tip them 10 Quai or like whatever it is.
And this all happens on the L1. I mean, like there's this, the whole system is designed. You're not doing this on Lightning. You're not doing it on an L2. Like this is like happening on the L1.
It's happening on the L1, and it's happening in such a way that it actually feels like real-time features.
Yeah.
So one of the things that, happened, and this is a cool feature that we like just added, is we talked about like that 8-second settlement time. That means it's actually been included in a block and processed. But what you can actually do is the expectation for a transaction to get around the network is sub 2 seconds. But then there's a Poisson process for inclusion in a block. So
What'd you call it?
Poisson.
A poisson? Like a poisson? Oh, a
Les
poisson.
poissons,
Les
les poissons.
We're talking about a little.
Les poissons.
We're talking about a little POISSON. Is that what we're talking about?
Yeah.
Paul, why don't you pull that up on Grok? What is that? You want to define that? What you just said?
So it's basically this it's just like a property of a randomized process in terms of how long it takes for that randomized process to happen. So the mean version of that, which we would call lambda, is our expectation time, but there's like this long tail. And like you see it in Bitcoin, right? Like our mean expectation for a Bitcoin block time is 10 minutes, but sometimes we get super fast blocks that happen in 10 seconds. And then other times we get like really, really fucking unlucky and it takes like an hour to find a block. If we were to graph that, like it has this sort of like decaying exponential look, which is called a Poisson distribution. And lambda in Bitcoin's case would be 10 minutes. In Quai's case, it would be 5 seconds. But we still suffer from like that very long tail. So like you can still get 6x block times periodically in the system,
randomly. It could be
just because it's part of the distribution, right?
Yeah.
So
very rare, but it happens.
It's rare, but it happens, right? So what we do, because we're trying to function as payments, the work shares get the transactions around the system sub 2 seconds into a proposed block. So if you build an application and then connect it to an RPC point, you can actually operate on the proposed blocks, not the finalized blocks. And then the majority of the time for most things, it doesn't even change once the block is mined because there's no conflicting transactions. In the case of like a swap, maybe your slip like marginally changes a little bit, but it's only like a marginal change over what's first reported and pending versus what gets included. So you can actually come up with what feels like Solana performance, where you click and within sort of like the perception of your human experience, it feels like an instantaneous like Web 2 experience, even though it's technically not fully finalized. You're kind of doing some type of like speculative execution and saying it's going to finalize and it's going to look like this, but it pops up in your system as like pending. And then 99% of the time, it just executes in the exact same way. And then 1% of the time, it executes in a slightly different way, but it's relatively unnoticeable by the user, but is what you have to do ideally to get systems that look like instantaneously like Web 2 systems, even though they're decentralized as Bitcoin in terms of the number of nodes, how they're operating, how data is propagating, like, and who controls the network. So you can have, 10,000 global nodes, but you can then run an app that still feels very close to Solana, even though you have 10,000 nodes rather than 12. So that's like a trick that we kind of like shipped that allows something like Kipper to feel like that.
Yeah.
Like you literally like click the like button and within a second a thing pops up, and within your perception of a second, it feels like it's a completely instantaneous process.
Speaking of nodes, what is the cost? What do I need to run a node on Quai? Is there any incentivization to run a node as someone who has Quai? And what is that? How many nodes currently do you guys have running? I guess is a good question. New network here.
I don't know if we have a good stat on mainnet. We had a better stat in testnet. And we had something like 2,200 nodes running.
That's pretty impressive.
I think the number's probably quite a bit lower now, but I don't know how many it is because.
Is it more than 10?
Oh yeah, no, it's a lot.
Subtle jab at Solana.
Yeah, no, it's a lot more than 10. But there's major pool operators that are integrated, and it represents like, unfortunately, like 80% of the hash right now. So there are a bunch of nodes running, but a lot of the hash rate is going through pools, and that's unfortunate. Because
you don't even need a pool, right?
You don't technically need a pool. That's right. So we actually came up with a whole thing that we're launching. We added a secondary feature. We call it a D pool. So the reason that you go to a pool is because you have to, in Bitcoin, it's because one reason is intermittent payouts.
Yeah, it just kind of smooths your payout.
Yeah,
gives you consistency.
but the other, and so in Quai, we solve that with work shares. So like you don't really have the smoothing problem as much. The other reason you're going to a pool is because you trust them to create like valid block proposals. You trust them like not to fuck you like with payouts, right? And so you want to go to like a pool that's like bigger and more reputable because like you're kind of on the hook for some period of time, like for them to perform, you know, uptime and like actually pay you what they're supposed to pay you, et cetera, et cetera. So there's like this trust element to it. And what we figured out is there's a way, there's like two steps to this. So one step to this is one way for a pool to operate is they give you a job and it's a hash, and your job is just add a nonce to that hash. This is grinding to try to create a block. But you don't know what that underlying hash is. And so what the pool can do is they can actually just inject their payout 1% of the time. And then they'll get 1% fee. But now the problem is, as somebody who's consuming this hash, I need to know that I'm indeed only paying this pool 1%. So we need to create like a validatable system that allows us to figure out if the depool operators are actually taking the fee that they're advertising. And so we came up with this concept of depools, which is cool because one, in the first iteration, if you sort of trust the depool to take the right amount of fee, I can mine without having to run a node, without having to go to like a centralized pool. Any like one of the nodes in the system can be my depool endpoint. But the problem is I need to trust them because I instantaneously don't have an understanding if they're like taking the fee that they are advertising. But what we figured out how to do is actually create a signature scheme against the proposed blocks that in the node will allow a analysis to be done to figure out statistically if the depools are being honest or not. And then what that does is it makes every node in the system able to operate as a pool operator that's completely trustless of the grinders. So instead of having to go to a centralized pool operator, you could just start your system and it will try to find the lowest latent peer relative to you that has good statistics in the network in both terms of liveliness as well as payouts. So like the whole thing is decentralized and that there's no trust in any of the systems, and you can bake it in completely into the node. And then all you have to do when you turn your node on is to say like, I'm willing to be a depool operator and this is the rake I'm willing to take. So we're working on this like trustless piece of the system, but effectively once we ship it, everybody in the network
Could potentially be their own pool.
is going to be their own pool operator.
Have an incentive to run a node.
And because latency is so important in our system,
Everybody
you want to find a block block builder who's very close to your grinder. So if Hero Miners is running and everyone's like going to Hero Miners, but they only have like 1 or 2 endpoints, there's actually a geographic advantage
to not use Hero Miners.
Miners because it has a lower latency of the block proposers. And in a competitive system,
we're talking about, you know, latency matters because the blocks are coming roughly every 5 seconds. Is that kind of the idea?
Latency matters hugely for miners, right? If you can take your latency of your peers from 1 second down to half a second, you've reduced your uncle potential by half.
It's why historically, it's why you connect to a pool node that's closest to you geographically.
Well, and you've potentially increased your revenue by 10%.
Oh, wow.
Right. So there's actually like
5 second block,
very strong
5 second block times. Yeah, I mean that's significant.
There's a very strong incentive to optimize your bandwidth and optimize who you're proposing to and who you're mining to. And that's why like the subnetting is so powerful in the system because there's a strong incentive to optimize all the latent factors. And because of that, the system is like incentivized to figure out how to operate faster, which as the system grows, it actually makes the system more efficient, which is like a super cool feature. But that's like the next thing that we're going to ship is that trustless aspect of the nodes, which then is going to make every node operator potentially get revenue.
Which incentivizes nodes. So you're saying right now there's really no economic incentive to run a node unless you're using it to mine for yourself, or
unless you're using it to mine or as an RPC. There's no economic
Can you
incentive.
define an RPC? Define that.
Remote protocol. Don't know what this
Explain what it does.
Basically, it's like the API for the blockchain. So like if you have a node, you have these endpoints, and I can like call the endpoints to like find something out about the blockchain.
Okay.
So if I'm like, what's the current block number?
Mm-hmm.
Okay, cool. What's the balance of my account? Like I ask it that question to that to that RPC endpoint, and then it like responds. It's like an API basically.
Gotcha. Okay.
It's like the node APIs.
Fascinating.
But it's coming from the node. So it's not like an indexed service API, it's coming from the nodes. And that actually leads us into one other thing that we're doing. So in a work-based system, there's this very unique thing that happens. And this is like littered all over Quai. So like it's very funny. There's like a few concepts, and if like you use them correctly, they can do like 10 different things for you, which is like pretty magical. But there's this concept of proof of work. Have you heard of this before?
No. Proof of work.
So if I want to know if a transaction is settled in Bitcoin, I can go to blockchain.com and be like, hey, is this settled? And then as long as I trust blockchain.com, they can be like, yes, this transaction is processed, or no, it is not processed.
Is this what Stacks on Bitcoin does?
I don't think so.
You're not familiar with Stacks, okay?
You
are familiar with it.
I'm familiar with Stacks. I don't think they leverage POPOWs or NEPOPOWs.
Okay.
So what happens is, you go to blockchain.com, you ask this question, and if you trust blockchain.com, they can give you an answer. Or your other option is you can run a node. And then you can query your own node because you trust it basically, and you know that it's like representative state as long as it's well connected and synced. And so then that like creates trustlessness, but the overhead for that is that you have to run a Bitcoin node and it has to stay in sync. But there's this interesting property with work. And so if I went to any node in the Bitcoin network and I said, is this transaction been processed? As long as I'm aware generically of the current block number, they could give me a proof of work, which is basically this transaction is included in the transaction set, and I can prove its inclusion via what we call a Merkle path because it's included in a Merkle tree, right? And I can then show that this block header, if I unfurl the Merkle path, contains this transaction.
Yeah.
And then I can just show you the headers after that block that transaction is, say, 6 blocks deep. And so with, in this case, maybe 1 to 2 kilobytes of data, I could provide you a proof of work that would give you confidence that your transaction was processed in the chain. Now, for me to spoof that transaction, I would have to independently mine 6 Bitcoin blocks.
Yeah.
Which is hugely fucking expensive.
I mean, isn't this the same thing as just checking a blockchain explorer?
No, so a blockchain explorer doesn't prove it to you. You trust the explorer to index the data, but there's no proof that you can validate at your endpoint that that's indeed true because you're not creating the proof and the data. You're just saying whatever the blockchain explorer is telling me is indeed correct, or if I'm...
You're just accepting that by default.
That's right.
Essentially.
Right. So unless you're running your own node, there's no like intermediate step where you can do this proof. But Bitcoin can do this. Like it's possible because it's a work-based system and they're using Merkle trees to, put the transactions into the blocks. So this is like 100% possible within Bitcoin. You can do this. It's just not done.
So also, I think there's something called simple proof that's doing. I think they're hashing a Merkle tree or something like that, and they're just they're adding that to a Bitcoin block. I mean, I don't know if it's not the same thing. Maybe it's not the same thing what you're talking about, but like election results or whatever, they're taking a picture on election night and they'll turn that picture into a hash. I mean, and they'll put it in the data.
That's more like Factum. It sounds like. Yeah. If you're familiar.
I'm not familiar with Factum.
Factum is like super old school, like on-chain proving of like information.
Interesting.
Actually, out of Austin, Jon Snow, I think, did that, and he was like one of the guys that like did the early Bitcoin meetups. It was one of like the earlier like consistent Bitcoin meetups and conferences. Anywho, that sounds Factum-like, but the point being is you can technically create a system where you can prove things without having to run nodes if you're a work-based system. So in Quai, because we're a work-based system, the actual consensus of like how this hierarchy of chains is running is technically running on proof of works. So like when you're just mining a shard, you're kind of getting proof of works from everybody else, and you're figuring out what to do based off that over time. So you can just mine one of these things, and then based on these other sort of proofs that you're receiving, you know what to do, even though I'm not keeping state in another shard. So like there's already like an implicit design criteria of proof of works in this system, and like they're known to be secure. And then there's an extension of proof of works that is called non-interactive proof of works, which is technically what you should be using if you are running, or if you want a proof that's completely independent of the system prompt, so to speak, of the current system state. So a proof of work, you need some data to validate, or some interactivity to validate, rather. In a non-interactive proof of work, you don't. So in our system, because we have these properties, we are building into our SDK the only piece, all the nodes already can produce these proofs. The problem is our SDK can't yet validate them. So like the missing piece of this is allowing the SDK to validate the proof. But once we have that, what you can do is any application like imports the SDK. And they can just ask the SDK a question like they would ask any other Ethereum EVM-like system a question. They're like, is this transaction processed? What is my balance? Whatever it is. What can happen in the back end is the SDK can figure out how to route that question. They can get a proof in return. They can validate that proof, and then they can return it to the application. But importantly, I don't have to go through a trusted RPC or an indexer to get this proof. I just import the SDK.
Explain what an SDK is.
Software development kit. So when you want to sort of access an RPC, you could do it directly, but there's sort of tools, state managements, and abstractions that are like happy that you want to make that process a lot simpler. And so if you're developing an application in JavaScript, you just like import quais.js, and it gives you the features that allow you to very simply interact with a node. In this case, a lot of, in the traditional sense, you'd be interacting with an RPC. So like in Ethereum, sort of all traffic goes through Etherscan and Infura. Like the nodes in the system, like nobody queries the nodes because you don't have proofs and you can't trust what they say. So the reason that you use Infura or Etherscan is because they're known, trusted entities, so you can trust what they tell you because they're known and trusted, but you're explicitly trusting them. And so your access to the system and the traceability of what you do in that system is completely dependent on those endpoints, right? So like they can track your IP address, they can like look at what you do, they could potentially censor transactions, they can throw them from the mempool. If they go down, you don't have access to Ethereum. So even if you have a decentralized system like Ethereum, to whatever degree that is, if you pipe it through these indexers, like Infura and Etherscan, it's no longer decentralized. So there was actually a time I was at East Denver and someone was trying to buy a hardware wallet and we're trying to use MetaMask. But like for that 30 minutes, like Infura was down. So we're sitting there at a conference trying to do a peer-to-peer transaction using a non-custodial wallet, but because the indexer is down, which is a centralized dependency in that system, like we couldn't transact. And I'm like, fuck, right? So in the system of Quai, once we get the SDK to be able to validate proofs, the data consumer becomes agnostic of the data provider. That means every node in the system you can ask a question to, and you don't care who you ask as long as you get an answer. So in the same way that you can decentralize the pool process through the construction of D-pools, you can decentralize the RPC process through the use of Nepo BAUs. But the cool part is you can get it ubiquitously used by embedding it in the SDK. So the developer has no fucking clue about this. They're just script kidding, include quais.js like any other application. And all the magic is happening on the back end and the routing, the proving, and everything else. And then the next step you can get to is you can create a data market. And so you can actually do micropayments, potentially hash-based micropayments to the endpoints. So you have a second revenue model for all of the nodes and you encourage more nodes to be on the network. So then as a node operator, I can not only make money by running a D pool, I can also make money by running a trustless RPC provider that automatically gets pinged when Quais tries to route a transaction.
Wow. I think this is a good closing point. I can tell you don't care about what you're working on at all. I can just you just seem completely disinterested in this.
Well, so the
I love it, bro. I think it's awesome.
The implications of this are a couple fold. One is you encourage greater decentralization because you give nodes a economic reason to exist. If they're economically incentivized to exist, it means that their contribution to the network is greater than what they're taking from the network.
So they're a seed, not a leech.
They're a seed, not a leech. That's exactly right. And now I don't need to altruistically go out to everybody and like people that come to a meetup and say, guys, decentralization is super important. I need you to altruistically like buy this thing, plug it in, and like leave it in the background of your home. I can say, you can make money.
Yeah.
Which is like how you get sustainable outcomes in the system. So there's this decentralizing thing that as these systems work and the markets come online and they become liquid, you just start making money by providing the service. It's like a beautiful system of decentralization. But then the other piece of it is it's how you scale. And it's how you scale in a robust way. So if you said you're going to go from 1 user to 1 billion users in a year, even the like most cracked DevOps team would have a hard time doing that. And you would not have 6-9 uptime. Fucking impossible, right? But if I say that you can make money and I'm going to distribute that process amongst thousands of node operators who are competitively trying to solve this problem and earn business, that is how you scale without limit to growth size or growth rate. You can literally go from 1 to 1 billion and the network is going to figure out how to do it.
Yeah.
And it's going to do it in this like incredibly awesome, incentivized, decentralized, adaptive way, which is super cool. So that's how you can like take this and say like, there is no centralized dependency. Like that's the whole point of the system. Like everything in this design is saying, what has happened? How do we fix it? Nodes need to make money. How can they make money? D-pools, they can make money. RPC, they can make money, right? That is how you solve that problem of decentralization in the long term. And that's how you get scale as well. And that's how you get something decentralized so that no matter what happens, I can always use the network. As long as I have an internet connection, like I'm going to find somebody in the network to hit. There's no centralized dependency. I don't need to know Infura. I don't need to know a DNS. I don't need to know shit. It's just going to work. And it's always going to work. And unless you can fucking blow up every single node on the planet, it will always be there and you can't shut it down.
Yeah, I love it. We'll close off here. We'll be back for episode 5.